Today we're going to be looking at solving systems of equations, and we're going to solve them by graphing. So when we solve by graphing, just a reminder, we have our slope-intercept form, which is y equals mx plus b. M is our slope, but in terms of a graph, if we're doing things by hand, that's our rise over our run. And b is where we begin when we graph, and that's where the graph goes through the y-axis, or the y-intercept. So first of all, what's a system? So a system is when you have more than one linear equation. That's what we're looking at right now, linear systems. So we're going to graph two lines. So graph the first one, then we're going to graph the second one. Then you're going to find where the two lines intersect, and then you state your answer as an ordered pair, and that ordered pair would be your answer. So let's look at this. So here you have two lines. Both are in the proper form, so they're ready to go in slope-intercept form. So for this top one, y equals x plus 2. I'll go to the y-axis, and I'll go to 2. And then from here, I use the slope, which is 1. So I would go up 1 to the right 1. Now, just because I know I'm going to need an intersection, I'm just plotting this all the way out for right now. So as I connect these, they might not be perfect, but hopefully we'll still see the intersection. So there's that top line. For the second line, that y-intercept is -2, and the slope is 3, or 3 over 1. So I'm going to go up 3 and over 1. Okay, so now I can already see where they intersect because I just ended up with it. So I'm not going to graph additional points here. I'm going to go ahead and connect them. Okay, so now the solution is going to be wherever the two lines are intersecting. So it is right there. And that point would be the point 2, 4. So 2, 4 would be our solution. What does it mean to be a solution to a system of equations? So if you have a solution to one equation, it just means that it would make that one equation true. So here, if you have a system, then you're looking for a point that makes both of the equations true. So let me plug some things in here. We know that in the ordered pair, 2 is the x and 4 is the y. So in the top, if I substitute what I just got, I would have 4 equals 2 plus 2. So notice I replaced y with 4, x with 2. So is it true that 4 equals 2 plus 2? Yep, sure is. Then if I check in the second one, I would have 4 equals 3 times 2 minus 2. Well, 3 times 2 is 6. 6 minus 2 is 4. Does 4 equal 4? Yes, it does. So here we have an ordered pair that makes both equations true. Next up, so same thing, we're still just graphing, looking for where the two lines intersect. So in the top one, the y-intercept is 0, and the slope is 2. So I'm going up 2 over 1. In the next line, the y-intercept is 3, and the slope is 1. Okay, now I see where they intersect, so I'm going to stop, continuing plotting the points, and I can tell that my answer is right here, and that is the ordered pair. Let's see here, 3, 6. So 3, 6 is the answer. And again, I know that this is correct because if I plug in the x and the y for the top one, y would be 2 times 3. So does 6 equal 6? Yep. Next one, 6 equals 3 plus 3. That's true also. You don't have to check every time by hand, but it is a good practice to mentally take a second and make sure that your answers make sense. Next up, top one, we have a y-intercept of 2, and the slope is a -1/2. So we will go up 1 and to the left 2. And again, just taking this as far out as I can for now. Next one. The y-intercept is 6. And then the slope is positive 1/2. Okay, I got the intersection. So my answer is right here. And that is the point. Looks like -4, 4. Next, here we have the line 2x plus 2, so y-intercept is 2. And then I would go up 2 over 1 for my slopes. And then the next one, y-intercept is -1, and we go up 2 over 1. Okay, so now I'm still plotting points because I don't have a point of intersection. So it's going to be hard to see because my lines are not drawn perfectly. But these two lines, they're never going to intersect. And we call lines that don't intersect parallel. So these are parallel lines. And if they never intersect, then they're not going to have an answer. And so the answer to this would just be no solution. Last example here. Top one, y equals -x plus 7. So there's my y-intercept at 7. My slope is -1 over 1. And then I notice on the second line that y is not by itself. So this is not in slope-intercept form. I need to divide everything by 2 first. And I get y equals -x plus 7. Now notice, that's the same as that. So what this means is my second line also has a y-intercept of 7, also has a slope of -1, and these two lines are right on top of each other. So if the lines are on top of each other, that means they have multiple points of intersection. In fact, every single spot on the line, the graphs are intersecting. So these two would have infinitely many solutions. So this means there are lots of ordered pairs, in fact, infinite amounts of ordered pairs that make both of these equations true. Your assignment for tonight is going to be in Delta Math. You have a work page that has coordinate planes on them, so you'll graph there and use that to show your work. Good luck.